So we have the function x cubed minus 3x squared, and we're on the interval -1 to 3. And we got a few things we need to do. Number one, we have to find the first and second derivative. So f prime of x was just the power rule twice. So we'll have 3x squared minus 6x. And for the second derivative, again, just the power rule a couple times, 6x minus 6. Now, to find the critical points, we set the first derivative equal to 0, and we find where it's 0 or undefined. This is a polynomial, so it's only going to have places where it's 0. We can factor a 3x out of here, and we get x minus 2 equals 0. So we have critical points at 0 and 2. Our next step is to identify any inflection points. Those would be any zeros in the second derivative. So we set 6x minus 6 equal to 0. Solving this, we're going to get x equals 1. And we can see that the second derivative does change signs at 1. It's just linear. So we're going to have an inflection point at x equals 1. And specifically, it'll be at the point 1 comma f of 1, and if we plug 1 in here, we get 1 minus 3, or -2 is our inflection point. Now, we need to test to see if our critical points are maxes or mins. And so we can make a number line and put on 0 and 2. And remember what we're testing. We're testing the first derivative, where it's negative and positive. So bringing that back in, here's our first derivative. So if I were to put in -1 into my first derivative, or we can look at the factored form, sometimes that's nice, I get a negative times a negative, which is a positive. That tells me my original function should be increasing. I could plug in a test point between 0 and 2, say 1, positive, negative, so that'll be negative, tells me my original function will be decreasing. Lastly, for any values greater than 2, I can see I'll get a positive and a positive. So my first derivative is positive, which means my function is increasing. So notice here I've got a max at 0 and a min at 2. And if we wanted to find the global max, or excuse me, let's do the, so the local max is at the point f of 0, which equals 0. The local min is at f of 2, which is 8 minus 3 times 4, which is 12. So 8 minus 12, so -4. Now we want the global max and the global min. We're guaranteed to have those because if you remember, we were on a closed interval. So we also need to check f of -1 and f of 3 to find our global max and our global min. So f of -1 gives us -1 minus 3, which is -4. And our global, or excuse me, at our other endpoint 3, f of 3, we have 27 minus 27, which is 0. So, kind of an interesting case here. We have two global maxes. Our global maximum value is 0. Happens at a couple places on our interval. Our global minimum, we can see, is -4, and it happens at a couple places. Now we're guaranteed that's the absolute max and the absolute min because we are on a closed bounded interval, so by our extreme value theorem, we can see that these are the maxes and mins. Now if we wanted to, say, get an idea of what the graph of this function looked like, well, we know it's increasing up to 0, 0, in fact, decreasing down to 2, -4, and then increasing after that. And so here is what we could see in a graphing calculator, mimics exactly what we just saw. Increasing up to 0, decreasing to -4, and then increasing from there on out.